Hey guys, welcome back. Today is day 66 and it is our first day on learning how to factor. So what is factoring? Factoring is the process of finding the factors of a polynomial. Okay, what does it mean? Well, factoring is like reverse multiplication. All right, so last unit we learned how to multiply binomials and polynomials. This unit we're going to go backwards and say, well, what can I multiply to get a certain polynomial? The first step to factoring is to find the greatest common factor. So the greatest common factor, and that's also known as the GCF. All right, the GCF, when working with polynomials, can be numbers and or variables. Okay, so our first example, we have the two monomials, 30n cubed and 42n squared, and we want to find the greatest common monomial factor of the two of them. So we're going to split them apart and we're going to treat the coefficient, which is the number piece, and the variables kind of separately, and then we're going to put them back together again. So if I look at the two numbers 30 and 42, I'm going to start with 30, and my factors of 30, I always start with 1, would be 1 times 30, 2 times 15, 3 times 10, and 5 times 6. Okay, so we listed them all here. We've got 1, 2, 3, 5, 6, 10, 15, and 30. Okay, so there's all our factors of 30. Doing the same thing for the number 42, I have 1 times 42, 2 times 21. I've got 3 times 14, and I have 6 times 7. So I listed them all here. The greatest common factor would be 6. Okay, so that's looking at the coefficient piece. Now the variables, if I have 30n to the third, I have 3 n's that are multiplied, and 42n squared means I have 2 n's that are multiplied. So the common ones would just be 2 n's or n squared. So putting it together, the greatest common monomial factor would be 6 n to the second power, okay, or 6n squared. Okay, keeping in mind when you're dealing with the variables, it's always going to be the lowest exponent if they're in common, okay? All right, so looking at some examples we have here, 12x plus 42y. So my greatest common factor of 12 and 42 would be 6. X and y, well, there's nothing in common. So I'm going to factor out a 6. And what I'm going to do is kind of reverse distribute or treat this like I'm dividing each of these terms by 6. 12x divided by 6 would be 2x, and 42y divided by 6 would be 7y. So we just factored out a 6 and we multiplied it by 2x plus 7. If I look at number 2, my number piece, the coefficient 4 and 24, my greatest common factor would be 4. Okay. And my x variables, if I have x to the fourth and x to the third, the lowest variable would be x to the third, or the lowest exponent. So I'm going to factor out a 4x to the third. All right. And since it's like I'm dividing by each of these terms by 4x to the third, or reverse distributing, I'm going to get an x. And 24 divided by 4 is 6, and it would be x plus 6 because the x to the thirds would cancel out. All right, number 3, we're going to factor out, well, the only thing we can factor out is a 3. All right, so if we took each of these terms and divided by 3, we would get 2x squared minus 5y. All right, so you guys can pause the video and try the next ones. I'm going to go ahead and just give you the answers here. So we're going to factor out, greatest common factor would be 3m squared, and this would be 3m to the 5th minus 1. Okay. Number 5, greatest common factor, 5 and 2, you can't factor out a number piece, but you can factor out a d squared. So this would be 5d to the third plus 2. All right, works the same way with trinomials. So in the case of number 6, we're going to factor out looking at the coefficient piece, we're going to factor out a 4 is the greatest common factor. And we have the lowest exponent for n is n to the first. So we're going to factor out a 4n. All right, and when we do that, 4n divided by 4n is 1, plus 3n, and then that's going to be minus negative 24 divided by 4 is 6, and it's going to be n to the second power. Okay, 7, we're going to factor out a 13 the s would be to the first power and a w squared. Okay, so when we divide both those terms by 13sw squared, and again, you can either write it in or you don't have to. Okay, but you are taking each of these and dividing it by it. You're going to get 1 plus 3s squared w. Number 8, you're going to factor out a 9ab. And it's going to be times 3b to the fourth minus 5ab squared plus 2a is going to be to the second power, and we don't need a b. Okay. And number 9, 9, 27, 36, the greatest common factor is going to be 9, and then we've got p to the first power would be factored out. So this would be times p to the fourth minus 3p minus 4. Okay, so again, when we start to factor, the first thing we're going to do is always factor out the greatest common factor first. All right, now the next thing that we're going to talk about are these kind of puzzles, all right, and it's called a sum and product puzzle. So in each diagram below, you're going to come up with two numbers so that you multiply, you get the top number, but those two numbers, when you add them, you get the bottom number in the x, okay? And just for purposes of kind of simplicity, I'm going to jump ahead and show you some examples starting with 7, 8, and 9, simply because I find that these are easier examples. All right, so 7, we want to multiply them together and get the top and add to get 25. What I mean by that, the two numbers I can multiply to get 24 that add up to 25 would be 24 and 1. Okay, the two numbers I can multiply to get 28 and add up to 11 would be 7 and 4. And you could say 4 and 7 too. You can switch the order. For number 9, if I had, let's see, the two numbers I can multiply to get 34 that add up to 19 would be 17 and 2. All right. Now we can also have some negative numbers in here. All right. Now remember, a negative 4 times a negative 4 gives me a positive 16, but it adds up to a negative 8. All right. If I looked at number 11, I know I'm going to have one positive and one negative. So I like to think when I have a negative, a lot of times I like to think of the numbers, the difference between the two numbers. Does it add up to 16? Okay. So if I took 18 and 2, I can multiply that to get to negative 36. Now, which one's going to be negative is going to depend on the bottom number, negative 16. So in this case, the negative 18 is going to be negative because if I add them together, I'm going to get negative 16. If I made the negative be the negative 2, then it would have been a positive 16. So you're going to pay close attention to that. And number 12, well, the two numbers, that one's pretty easy. You can just say 5 times 5 is 25, and that adds up to 10. Okay, so jumping back now to number 1, all right, using the same numbers, think about your factors of 48. Now this one gets a little more difficult, so maybe you think about your factors and you go, oh, well, 48, I could say 1 times 48. I could say 2 times 24. All right, maybe I say 3 times 14. I could say 4 times 12. And I could say 6 times 8. Okay. Now, because we're dealing with, oops, I think I made a mistake in there. Yes, I did. It's actually 3 times 16 in here when I did my factors. Oops, right here. Silly me. Okay, so 3 times 16 would be 48. There it is, and 4 times 12. All right, so looking at my combinations, are there any two factors where the difference would actually be 13? Okay, because see how we're dealing with positives and negatives, and if you did look at that, 3 and 16, if I said 3 times 16, which one would have to be negative to get to that negative 13? It would be negative 16. Okay, so 3 times negative 16 gives me negative 48. 3 plus negative 16 gives me negative 13. All right. Number 2, whenever you have them adding up to 0, you know it's going to be one is positive and one is negative of the same numbers, and usually that happens when it is a perfect square. All right, or the absolute value of it would be a perfect square. All right, 13, if we had the numbers of 14 and negative 5, that would multiply to get negative 70, and it would add up to be positive 9. Number 4, we could say 22, or actually negative 22 and 2. That would give me negative 44 when I multiplied, and it would add up to negative 20. All right. For negative 42, I can have a negative 7 and a positive 6. And negative 72, I have a 9 and an 8. And in this case, the 8 is going to be the negative, so that when I add it together, I get a positive 1. Okay, so this seems like a silly puzzle, but it's going to come in handy with when we start to factor trinomials. So we're going to learn a method called the X method. All right, and again, this is kind of taking what we did last unit and kind of going backwards. All right, so recall that factoring is like reverse multiplication. All right, the easiest way to factor trinomial is going to be to use, we're going to call it the X method. All right, it's also called the sum and product X. So instead of box, it's called the X. All right, and what's going to be really important is this is how we take a trinomial, which is in the form of ax squared plus bx plus c. And we're going to factor out the greatest common factor first, and then we're going to try to come up with two binomials that we could multiply together to get that, or kind of opposite of the foiling we did last unit. All right, so you can kind of read through all this, but it's actually going to make more sense when I start doing some examples. So I'm going to jump right into giving some examples. Always recall that if the polynomial cannot be factored, it's actually prime. Okay, so if I look at my first example, notice that this is in the form of ax squared plus bx plus c. And in that case, I can identify my a as 1, my b is 8, and my c is 15. You're looking at the coefficients and the constants here. I'm going to make an x. And when I make my x, kind of like we did with the puzzles, what's going to happen is I'm going to take a times c and I'm going to put it up top. And I'm going to put the b, or think of b for the bottom, I'm going to put it at the bottom of that x. And just like we did with the puzzle, we're looking for two numbers that when multiplied together equals the top, and when added together equals the bottom. Okay, so we're then going to find those two numbers, and we're going to call those two numbers m and n, and then we're going to divide both of them by the leading coefficient, which is a. All right, so in this first example, when I make my x, a times c would be 15, and my bottom would be 8. So just like the puzzle, now I'm looking for two numbers that I can multiply to get 15 to add up to 8. Well, let's try 5 and 3. Okay, and it wouldn't matter if I did 3 and 5. All right, I'm going to divide by my leading coefficient, which is 1 in this case. And anytime you divide by 1, we've got a weird thing going on there. That's a 3, and then this is a 5. Okay, so I'm now going to take this 5 and 3, and I'm going to break it into two binomials. My variable is x, so I'm going to say x plus 5, because that's a positive 5 I have on the left, and x plus 3, because I have a positive 3 on the right. So we just factored that trinomial into x plus 5 times x plus 3. Now if I took these two together and I multiplied them, foiling them, I would get x squared plus 3x plus 5x plus 15. Combine those middle terms, and I would have x squared plus 8x rather, plus 15. So that's a quick check. I can just multiply them and make sure I get what I started with. Okay, so this seems like a lot of work for what it's called the X method. For what we used to kind of do in the old days, we did what's called guess and check. All right. Now with guess and check, I'm just going to show you the same example with guess and check so you can see, because some of you might prefer to do it this way. But this method really works well when your leading coefficient is not 1, because that's where guess and checks gets really hard. Okay, so what I'm going to show you here is, let's clear this out. Okay, guess and check basically says, okay, what two can I multiply? Well, to get x squared, I know I'm going to have x times x. Now, what two numbers can I multiply to get 15? Well, if I did 15 and 1, my middle term would be 16. That's not going to work. Okay, maybe I'll do 3 times 5. Oh, okay, that one works. Okay, so I just did it using guess and check, where I'm kind of seeing that x times x is x squared, plus 5x plus 3x gives me my 8x, and then my last was that 15. Okay, but going forward, I'm just going to show it to you using this X method. Okay, So if I look at number 2, I first always identify my A, B, and my C. Okay, my A is 1, my B is 7, and my C is 12. I then make my X. A times C is 12, so that goes up top, 7 goes at the bottom. All right, I'm going to think of the two numbers I can multiply to get 12 that add up to 7. Well, that would be 4 and 3, or 3 and 4, doesn't matter. I'm going to divide by that leading coefficient. And so this shows me my variables are y, so this would be y, and that's a positive 4, so plus 4 times y plus 3. There it is, my two factors. Okay, number 3. I'm going to start again. My A is 1, my B is 1, my C is negative 12. All right, I'm going to make my X. A times C is negative 12, and I have a 1 at the bottom. The two numbers I can multiply to get negative 12 that add up to 1 would be positive 4 and negative 3. All right, I'm going to divide by that leading coefficient, which is again 1. And this may seem silly because we're always dividing by 1 so far, but eventually we're going to divide by 2 or other numbers. So I get these two numbers, and these are my M and my N. I'm then going to take them, and my variable is Q, so it's Q plus 4 times Q minus 3. And there's my answer. So if I FOILed this, I would get what I started with. Number 4, I identify my A is 1, my B is negative 13, and my C is 22. Now remember, with all of these examples, the first thing I'm doing is actually factoring out the greatest common factor, but there haven't been any, okay? So I've got my A, my B, and my C. I'm going to make my X, and when I make my X, A times C is 22, so that would go up top, and a negative 13 would go at the bottom. I can then take 11, let's say I can take a negative 11 rather, times a negative 2, and that's going to give me positive 22, and when added together it gives me negative 13. I'm then going to divide by that 1 again, and I have negative 11, and I have negative 2. So my variable is X, so this would be X minus 11 times X minus 2. And that would be my answer. Okay. Now the first thing I want you to do after you factor out the greatest common factor, also note that you cannot have a leading coefficient that's negative. All right. That means your A cannot be negative. So in this case, I'm going to start by factoring out a negative 1. All right. So I'm going to factor out a negative 1, and this becomes x squared minus 10x plus 21. From there, I'm just going to factor the trinomial that's in the parentheses. So my A now would just be positive 1, my B is negative 10, and my C is 21. So when I make my X, I've got 21 and negative 10. The two numbers I can multiply to get 21 would be negative 7 and negative 3, because when they add together it would be negative 10. I again divide by that leading coefficient of negative 1. All right, and that negative 1, I'm just going to write it as a negative, and on this side we have a negative 7, so this would be x minus 7, and the other one would be an x minus 3. So there's our solution. All right. If I looked at number 6, my A is 1, my B is 1, and my C is 3. When I make my X, A times C is 3, and my B is 1, I don't have any numbers that I can multiply to get 3 that add up to 1. Think about it. My only two factors of 3 are 3 and 1. And if I add 3 and 1, I get 4. Or even negative 3 and negative 1, I still get a negative 4. So this is an example of a prime polynomial if you cannot factor it. Okay. Looking at number 7. So again, I'm going to start by factoring out that negative. So I've got b squared plus 14b plus 48. I identify my A is 1, my B is 14, my C is positive 48. When I make my X, A times C is 48, B is the bottom, I got 14. The two numbers I can multiply to get 48 would be 6 and 8 or 8 and 6. The order doesn't matter. I then divide by that leading coefficient, and I have 6 and 8. So I don't want to forget about the negative. I bring that down, and this would be, my variable's b, so this would be b plus 6, and this would be times b plus 8. Okay. Now number 8, we finally have an example that has an a that's not 1. Here it is 2, our b is 7, and our c is negative 15. When I make my x, a times c is now negative 30, and my b is 7. Okay, so 2 times negative 15, all right, is that negative 30. The two numbers that I can multiply to get negative 30 that add up to 7 would be a 10 and a negative 3. Okay, now this is what's important. You divide by your leading coefficient. Okay, now on the left, I've got 10 halves. That can simplify to be 5. But on the right, I have a fraction, negative 3 halves. You make sure that that fraction is simplified. Well, 3 halves is already simplified. And this is where it's going to get a little bit different. So, for the left side, our variable is w, so we just have w plus 5. But on the right side, the denominator becomes the coefficient, so the 2, w, minus 3. Notice we took the 2 and we slid it up to be the coefficient, and then because it's negative, it's minus 3. You never have the leading coefficient be negative. So instead, you're going to make that constant be negative. So if I took this and I FOILed it, all right, I would get 2w squared plus 7w minus 15. So this is much harder to do with guess and check. If you just wanted to start out and say, oh, okay, well, I've got these two binomials. Maybe I want to do 2w times w. Then you have to start playing around with the combination of numbers that would give you negative 15. That would then give you a middle term of 7w. It gets a little bit harder. So I highly recommend at this point using this X method. All right, let's look at some. At any point, I really want you to pause the video and try some yourself. Okay, so again, our A is 6, our B is negative 13, and our C is 2. There's nothing that we could have factored out. When I make my X, 2 times 6 is 12, and I have a negative 13. The two numbers I can multiply to get 12 that add up to negative 13 would be negative 12 and negative 1. And then I divide by the leading coefficient. So in this case, I've got a negative 2, all right, and then I have a negative 1, 6. So the left side, my variable is y, so it's just y minus 2. Now this negative 1, 6, remember the 6 becomes the coefficient, 6w, and then we have minus 1. So there's our solution. All right, number 10, again, pause the video at any time and try it. A is 3, B is 5, C is 2. Okay, I'm going to take the 2, A times C, and I multiply, I get 6, and 5 down at the bottom. The two numbers that I can multiply would be 3 times 2 would be 6, and adds up to 5. I divide by the leading coefficient, and I simplify. So 3/3 is 1, and then I've got 2/3. So my variable's y, so this is going to be y plus 1. And then this is going to be, again, this becomes the coefficient, 3y, and it's positive, so it's going to be plus 2. All right. Again, if I FOILed it, I would get what I started with number 10. All right. 11. Now, 11 does have a greatest common factor. If I look at 6, 15, and negative 9, I can factor out a 3. So this is going to be 2m squared plus 5m minus 3. Okay, now I'm only going to use the A, B, and C from what's inside the parentheses. So my A is going to be 2, my B is going to be 5, and my C is going to be a negative 3. I make my X. A times C is going to be a negative 6, and I have a positive 5. The two numbers that I multiply with number 11 to get negative 6 would be 6 times negative 1, because when added together it becomes 5. I'm then going to divide by that leading coefficient, and I'm going to simplify. So 6/2 is 3. All right, and I'm not going to forget now, my variable is m, so I already factored out a 3, and this is going to be m plus 3, because on the left side I have this 3, but on the right side I've got 2m minus 1, and there it is. Okay. With number 12, we're going to factor out a 2 as the greatest common factor. So we've got 2 times 2y squared plus 7y plus 3. I'm going to make my x. My a is 2, my b is 7, and my c is 3. So I've got a 6 up top and a 7 down at the bottom. Now the two numbers I'm going to multiply would be 6 and 1. I'm going to divide by the leading coefficient of 2. So with that, I'm going to take that, okay, I've got 3, so this is going to be 2 times y plus 3. That's a positive 3. And then the second one, the denominator becomes the coefficient, 2y plus 1. Okay. All right, so if I look at 13, I cannot factor out anything. If I take a times c, all right, I get, again, my a is 2, my b is 3, and my c is 4. So a times c is 8, and then 3 down at the bottom. Now if I look at this, my only factors of 8 would be 8 times 1, 2 times 4. There's no combo that when added together equals 3. So this is an example of a prime polynomial. All right. So number 14, okay, 2 times, so if we factor out a 2, okay, greatest common factor is 2, so this is going to be 3x squared minus 13x minus 10. Okay, when I look at this, I do my a is 3, my b is negative 13, and my c is negative 10. Okay, when I multiply, I get a times c is negative 30 with a negative 13 down at the bottom there. The two numbers I can multiply would be negative 15 and 2. I divide by my leading coefficient, which is 3, and I simplify. So my factors are going to be 2 times, and this is an x minus 5, and then the 2/3 would become 3x plus 2. And there it is. All right. Okay, so try your homework. Bye, guys.